Hi, if you're thinking about insulation for your building, this short video is for you. I'm Frankie and I'm going to give you an introduction on where you can insulate, the types of products you can use and things you might want to think about regarding insulation. This video aims to help you understand how it could help your business reduce energy costs and carbon emissions. So what are the benefits of installing or improving insulation? It'll lower energy bills. Insulation limits heat transfer, keeping your building warmer in the winter and cooler in the summer. By ensuring your business is well insulated, you can reduce the energy requirement and cost of heating and cooling the premises. Buildings will take less time to heat up and remain warmer for longer once heating has been switched off. Lower carbon emissions. If heating and cooling units are using less energy, then your consumption of fossil fuels will be lower, lowering your carbon emissions. Improved EPC rating. Insulating your building may have a positive impact on the building's energy performance certificate rating. This is beneficial when selling or renting out a property, as better energy efficiency is appealing to potential buyers. Soundproofing. Insulation absorbs sound waves, therefore reducing sound transmission through a building. This leads to a quieter environment and more comfortable workspace. Thermal comfort. The term thermal comfort describes a person's state of mind in terms of whether they feel too hot or too cold. Insulation improves the control of heating and cooling of spaces, which can allow thermal comfort to be more readily achieved by employees and customers. So where should insulation be installed? When considering where to insulate, it's useful to consider your building's thermal envelope. This is everything which prevents the indoor heat from escaping through areas such as walls, doors, windows, floors, and the roof. Buildings should have a continuous layer of insulation or thermal barrier. You should first check that the current insulation is continuous. For example, checking that layers of roof insulation are not interrupted and fix any breaks. Then, the areas of highest heat loss should be prioritised for improvement, as this will make the biggest difference to energy use and therefore has the highest potential for cost and carbon savings. The main areas of heat loss are the roof or roof space, walls and floors. When talking about insulating roofs, there are two different ways in which it can be done: warm and cold roofs. A cold roof space is where insulation is installed inside the roof structure, between and over the joists. Installing it here means that the roof space will be uninsulated and the temperature will be close to that of outside. Any water tanks and pipework in this space, which will now be above the insulation layer, will require lagging or insulating to protect from frost. Another way to insulate is referred to as warm roof space. This is where the insulation is installed between the tiles and rafters on the roof, creating a thermal barrier between your roof and the external air above the building. This method of insulation will commonly use a rigid board type of material, and this insulation works by preventing heat from escaping through the roof while still maintaining a warm roof void. Another area to consider installing insulation is to your external brick walls. Generally, there are two types, cavity and solid walls. You can tell which type yours are by looking at the bricks. If they all appear one size and face the same direction, it's probably a cavity wall. If the bricks face different directions, so you can see the face and the side of the bricks, it's probably a traditionally built solid wall with no cavity. Walls in older buildings tend to be made in a solid double brick configuration. The construction industry began building cavity wall properties in about 1920, and these cavities were uninsulated until the building regulations made it a requirement in the mid-80s. Buildings which still have an uninsulated cavity wall can be insulated by drilling a series of holes in the outer leaf of the wall and injecting insulation materials using specialist equipment. Once the process is complete, the holes are sealed up with mortar. Solid walls work a bit differently, and there are other things to consider before insulating them. Traditional solid walls allow some water vapour to move freely through the bricks and stone. High levels of ventilation and drafts are also common in older buildings and help to prevent dampness in the building. Insulating an older building affects the way water vapour behaves and can lead to damage to the building fabric. Some of the problems with moisture movement and ventilation that may occur due to adding insulation creates a barrier to vapour movement. Insulation decreases the level of drafts around windows and through walls. Internal insulation makes the inside of a wall colder, which can result in vapour condensing inside the wall. And for those reasons, when choosing to fit solid wall insulation, it's important to consider ventilation and breathability of the products to prevent future damp problems. Breathable insulation products, membranes, plaster and paint can be used to allow moisture to move through walls, which is compatible with the way in which traditional buildings work. This will avoid problems such as mould and wet rot, which can affect the health of the building's users. If your building has solid walls, the next choice is where to install the insulation, either on the inside or the outside of the building. Installing external insulation can be less disruptive to a business and means that no internal room space is lost. The things to consider are: it can restore the existing facade, extending the lifetime of a building. It can improve the appearance of a building. It does not reduce the internal space available to your business. It's lightweight and relatively simple to install. Scaffolding is likely to be required. Installing insulation to the internal walls will require a substantial refit. Pipework, light switches, doors and skirting boards will need to be moved to accommodate the insulation, and the space will require redecorating. It's worth considering. It can be very disruptive. There'll be a loss of internal room area. There'll be no impact on external property appearance. No scaffolding will be required, and the noise insulation will be improved. Thermal mass. Thermal mass describes a material's capacity to absorb, store and release heat energy. Dense and dark surfaces are ideal for absorbing and storing heat. During the day, the thermal mass will absorb heat from sunlight, and as the temperature cools at night, heat stored in the thermal mass of a building's fabric will be slowly released into the building, helping to keep the temperature more stable. Choosing to insulate a building internally or externally will have a very different result on how the thermal mass of a building behaves. External insulation is much more effective in preserving the value of thermal mass in walls, helping to regulate the indoor temperature. In comparison, internal insulation causes the heat storage value of walls to be lost, and heat will leave quickly with the external air. How do I choose insulation products? So you've decided where to insulate and now need to select a product. There are a number of values that can help to compare products and their insulating properties. Lambda value. The lambda value may also be known as a K value. This measures the thermal conductivity of an insulation material and is independent of the material's thickness. A low lambda value means a good insulation material, as the heat loss through it is low. The lambda value unit is watts per meter Kelvin. R value. Insulation can be rated by an R value. This is a measure of the thermal resistance of the material, which indicates how resistant it is to heat flow. It's like the opposite of the lambda value and takes into account the thickness of the insulating material. The higher the R value, the more effective the insulation. If there are multiple layers of insulation, then the R values can simply be added together. R values have units of meter squared Kelvin per watt. U values. U values are used to describe the thermal performance of elements of a building, such as cavity walls or windows. U values are calculated for the building element as a whole. So for a cavity wall, the U value takes into account the thermal properties of the bricks, the insulation in the cavity, and any other materials such as internal plasterboard. The lower the U value, the less heat is transmitted through the fabric element. It measures the quantity of heat that flows through a square metre of the fabric element for every degree difference in temperature between inside and out. The unit is watts per metre squared Kelvin. There are lots of different types of insulation. Blanket insulation. This type of insulation comes in rolls and can be made of glass wool or natural breathable materials such as hemp, jute or sheep's wool. It's cost effective and good for larger obstruction-free spaces. The many insulating air pockets within the material work best when not compressed. Rigid boards. These are pre-formed rigid panels of insulation with high insulating values. They can be made from PIR or PUR or natural breathable materials such as wood fibre. Loose fill. This is a light material consisting of small particles which can be installed into awkward spaces without disturbing structures via a pipe. Common materials include cellulose and fiberglass. Structural Structural insulated panels. Prefabricated panels that can be used in the floors, walls or roof of a building. They consist of foam sandwiched between two rigid boards and tend to be used in new builds rather than as a retrofit product. Sprayed foam. This is liquid foam that's poured or injected into cavities where it expands and hardens as it cures. It's a versatile type of insulation which is designed to flow over obstructions. Vacuum insulated panels. Vacuum insulated panels are rigid, thin cores of material which are encased in an airtight aluminium foil lining. During manufacture, the air is evacuated from the panels, giving them excellent thermal properties. They can be used where space is at a premium, but they are expensive and must not be penetrated with fixings, as this would cause the vacuum to be lost. Insulating a steel-framed building. Single-skin clad buildings consist of single-skinned roofs and walls and are only really appropriate for storage purposes. If your building has single-skinned walls, you can apply insulation to increase their thermal performance and save on energy bills. If your building has internal office areas with suspended ceilings, it'd be a good idea to insulate above the ceiling with a material such as rock wool. This will increase thermal comfort for sedentary staff. There are a couple of other things you might want to consider before installing insulation. Damp and condensation. So adding or improving insulation can reduce ventilation or air movement in an area which can lead to moisture buildup. Additionally, because cold air cannot hold as much moisture as warm air, condensation is more likely to form in newly insulated spaces which previously were warmer. Condensation can create a damp problem, so it's important to ensure that any air vents remain uncovered during installation and the insulation is not packed too tightly around external walls and eaves. Regular checking of the areas around insulation is advisable to check that no condensation issues have arisen. Planning restrictions and building regulations. Some works may be subject to planning restrictions, so check with your local planning department before commissioning works, particularly for listed buildings or within conservation areas. Some insulation upgrades need to comply with Building Regulations Part L, Conservation of Fuel and Power, with the requirement depending on the type of building use and area being insulated. Your local planning department or qualified installer will be able to advise on this. So that's a brief introduction to insulation. I hope it's been useful. You can find out more about this topic by downloading our fact sheet. We also have lots of information on energy efficiency and renewable energy technologies that may be suitable for your business.